Hi again. This is the second video for section 5.5 for Algebra 2 Trig. The first one was just a proof of quadratic formula. And so now we have it. X equals negative b plus or minus square root b squared minus 4ac all over 2a. All right. We can use this now. Keep in mind, we're solving. We have a couple different ways we can solve. So some ways are easier than others. Always look for factoring. Factoring, you should be getting much better at it now. It should be becoming much quicker. Factoring, if a quadratic factors, it's the easiest. After that, if it doesn't factor, usually I go to quadratic formula, and last is completing the square. Okay, quadratic formula will always work if there's solutions. Completing the square will always work if there's solutions. Not everything factors nicely, so we always have those backups to factoring. But no matter what, we have x squared term and x term in this example. We got to set it equal to 0. 5x squared minus 7x plus 1 equals 0. Okay, looking at this, it's not going to factor. Just, 5x squared. We got to have a 5x and an x. It's the only options. For the 1, it's got to be a 1 and 1. There's no way we're getting to a negative 7. So it doesn't factor quadratic formula, okay? So you got to identify your a, b, and c values. We talked about this in the first section. A is 5, it's the coefficient of x squared. B is negative 7, it's the coefficient of x. C is the constant, it's 1. And now we plug them into the quadratic formula. We're solving for x, that's what this formula does. So negative b, that makes that a positive 7, plus or minus the square root. B squared, 49, minus 4 times a times c. All of this is over 2a. Okay, once you plug in your numbers, it's really just an order of operations. The square root is like a parenthesis. You do all the stuff inside it first. So 4 times 5 is 20, times 1 is still 20. 49 minus 20 is 29. That is all over 10. Now 29 is not a perfect square. It doesn't have factors that are perfect squares, and so leave it. We're getting exact answers. I should probably throw that in the question. Exact values. So we're going to leave it as square root 29. That is exact. And really, there's nothing else to do. There's no more common factors. There's nothing we can combine. Answers. Right there. Okay, quadratic formula. Somewhat quick, somewhat simple. But it's just a matter of identifying your a, b, and c values, plugging them in, cleaning up any of the numbers that you can. All right, finding the axis of symmetry and the x value of vertex. So the idea here, I have given you this formula before, but I want to kind of just show you where it comes from. If you just graph a generic parabola, parabolas have symmetry, and I don't want it there. I drew a nice one, but it's not where I want it. Let's move it close enough. Move it there. So it's crossing the x-axis here and here, which is at 2 and 1, 2, 3, 4, 5, negative 6. Okay, parabolas have symmetry. That means there's an axis of symmetry, and it goes right down the middle through the vertex. Now, because there is symmetry, and it's symmetric around that vertical line going through the vertex, left and right halves are equal to each other. So, where is that axis of symmetry? It should be halfway between these x-intercepts. So how do you find the halfway between two numbers? It's just an average. Negative 6 plus 2, divide by 2. So we get negative 4 over 2, which is negative 2. Okay, there is our axis of symmetry. It is at x equals negative 2. It's halfway between the two zeros, the two x-intercepts. So that's the idea here. Now, quadratic formula, we solve for x, okay? Other phrases for solving for x is finding the zeros, find the x-intercepts. They all mean the same thing. When you solve an equation, solve a quadratic equation, you're finding the x values where it crosses the x-axis. So with the quadratic formula, if we solved that equation, quadratic formula gives us those two zeros, negative b plus or minus, and I'm going to write them, I'm not going to write them separately yet, square root b squared minus 4ac all over 2a. There's our two x-intercepts. So now we don't know the negative 6 anymore. We don't know the 2 anymore. What we do know is this is where we're crossing the x-axis at those two values. So now, where is that axis of symmetry? Well, it was the average of those two zeros. Our two zeros are negative b plus and negative b minus the other stuff all over 2a. So if we get the average of those, negative b plus square root b squared minus 4ac over 2a, and we add that to the other zero, negative b minus square root b squared minus 4ac all over 2a. When you add these up, what you get is, looking at like terms, negative b plus a negative b is a negative 2b plus square root of b squared minus 4ac, and then we are adding a negative square root of b squared minus 4ac. Those just cancel each other out. Now we're adding our two intercepts and we're taking the average of them. Okay, so we're dividing by 2. So we got negative b, negative 2b over 2a. That is our numerator up here, and we're cutting that in half for the average. So negative b over 2, negative 2b over 2a is just a negative b over a, but we're dividing by 2, which is the same thing as multiplying by half. And so what we get is x equals negative b over 2a. I have shown you this equation before. This is one proof of where it comes from. Okay, this is the x value. This is the axis of symmetry. Okay, the x value of the vertex. Okay, we can say it a couple of different ways, but again, parabolas have that symmetry. And so the zeros of the quadratic, which is the solution, the quadratic formula gives us that axis of symmetry is halfway between those zeros, which is the average. So we add up our two zeros, it puts us here. So the axis of symmetry is negative b over 2a. It's x equals negative b over 2a. Let me see if I can raise the page up here. Here we go. So this is something to put into your notes. This is the formal version of this definition. This equation, x equals negative b over 2a, there is a calculus version of this proof. It's a little bit cleaner once you know calculus. Hopefully you'll see it next year. All right, so let's do one example here. You have an equation, f of x. It says write an equation for the axis of symmetry of the graph and find the coordinates of the vertex. Okay, so axis of symmetry is x equals negative b over 2a. There should be a space in that equal sign there. Sorry. Negative b over 2a. There we go. That's better. So our b value is a negative 2. Okay, coefficient of x. So the negative of a negative is positive 2 over 2a. Our a value is the coefficient of x squared. So we got 2 times 2. That's 2 over 4, which is 1/2. There is our axis of symmetry. It is also the x value of the vertex. So the question has two parts here. Write the equation for the axis of symmetry. That's that. And find the coordinates of the vertex. Well, axis of symmetry goes through the x value of the vertex. It goes through the vertex. So where is the y value of that vertex? Plug in that x value that we just found. So function notation, f of 1/2 equals negative 2 times 1/2 plus 3 plus 2 times 1/2 squared. which gives us a negative 1 plus 3. 1/2 squared is 1/4 times 2 is plus 1/2. So that gives us 2.5, which is 5/2. Okay, so coordinates of the vertex. X coordinate 1/2, y coordinate 5/2. Always put parentheses around a point. And that is it. Some of the stuff we had talked about before, but there was kind of a lot of proof of it, and that's what took the most time of this. But we've done all these types of problems before. So if you do have questions on any of this, please write them down as we're ending this video, and then ask them in the morning. Friday, having a weird schedule with the assembly, so come on in. You can just, if you're good with this stuff, you can just start working on the assignment. If not, ask your questions. Have a good night.